And we're live. Hi, everyone. Welcome to another episode of Stripe Dev Chats. My name is Cecil Phillip, and I'm really glad to be back. We have not done one of these in a little while because, well, we had our big company conference called Stripe Sessions, and that just happened a couple of weeks ago. And it was just really good to be in front of folks, and instead of just talking to folks online, we got to actually be with them and talk to them in person. So that was a lot of fun. But because of that, we had to put a pause a little bit on some of these live streams. But now we're back, and we're gonna get the show back on the road. And I'm really excited about today's episode because today, I have my friend Ryan here, and he's gonna talk to us about some of the lessons learned about building out Stripe Radar, which is our fraud detection product that we have. And so, Ryan, why don't we start off with just like a quick round of introductions? Why don't you tell folks a little bit about who you are and what do you do?
Well, thank you for having me on the show. It's exciting to be here. So my name's Ryan. I've been at Stripe about 4.5 years now, and that entire time has been spent on the Radar team and the Radar product. And as you mentioned, we essentially are Stripe's first product to stop fraudulent payments. So we're responsible for evaluating and providing merchants tools and the ability to kind of tailor to their fraud needs and decide what they want to allow or not allow to the Stripe network. And so I'm the tech lead for that product, and specifically I'm responsible for a lot of our data and ML systems, and I'm here to tell you a little bit kind of about that history, some decisions we've made along the way, and kind of where we're at now.
Yeah, when we talk about Stripe Radar, I kind of lump it under like the umbrella of like a lot of the other security concerns that we have as developers in general. And let me know if you feel the same way about this or not. But I feel like security is always the best when you don't hear about it, right? Like when it's working in the background and it's protecting you and it's doing the things that, keep us safe and secure. We don't see it, we don't hear it. Things that are happening in milliseconds and microseconds that are probably stopping a lot of bad actors from doing things to us in our accounts and our businesses. But a lot of the times they just happen and we don't hear about it, right? But then we go home and it was like, oh, it was a pretty nice day today, right? When in the background, all of the security folks, all of the fraud detection folks are working hard to make sure that we can continue doing some of those things. So I definitely appreciate your team and a lot of the work that you did. I'm really wanted to dive into that a little bit deeper. But before we do that, what I want to do is let's switch over to my screen and let's do a quick round of updates, right? Because again, we haven't been here for a while and a lot of stuff has been happening in the world of Stripe. So let's kind of just run through some of these really quick announcements. First one I want to talk about really quick is about like this deal we struck just a couple of weeks ago actually just last week with WhatsApp inside of Singapore. Now, what this actually enables is that, and I'm going to scroll down and zoom in a little bit, but if you're running a business in Singapore and you're using WhatsApp, particularly if you have a WhatsApp for Business account, you can actually start accepting payments within the WhatsApp UI, which I think is really cool. So you actually have the ability to, pretty much send like a checkout enabled experience if you're familiar with our Stripe checkout product. But instead of like going to a website or having to build a custom mobile app for that experience, it all happens within the context of WhatsApp. So you could do your secure checkouts. You can see like your billing and your subtotals. You know what I mean? You can do like our typical workflows that you would have. Again, all within the context of WhatsApp, which I think is great. So if you're in Singapore and you wanted to do business with Stripe and you're watching us right now, make sure you check this out. And again, this is only for folks that have WhatsApp for Business accounts. So like you just have a regular WhatsApp account, it's not for you. This is not what this is for, right? But again, if you have a WhatsApp for Business account, this is a great option for you to check out. Excuse me. Now, the next thing I want to talk about here is if you head over to our docs, right? And so this is on our Stripe issuing banking as a service thing. So right now you have the ability to customize SMS fraud alerts, which I think is really cool. So you can actually customize what are some like what rules would dictate what how can I put this? Like what incidents are going to trigger SMS text messages, and you can do that all using our APIs, which I think is really amazing. I actually didn't even know we had this until like late last week. But if you're using Stripe issuing, and Stripe issuing is another service that we have where you can actually issue payment cards on behalf of your company, right? So like actually issuing credit card, cards. We actually have the ability for you to kind of detect if any types of fraudulent activities are happening with those. And then now you can have SMS messages sent out to you or someone else in your company to be able to deal with that, which I think is a really good option. So again, this is all on our docs. Make sure you head over to the issuing banking as a service option, and you can see how you can turn some of that stuff on. Now, next piece that I want to talk about here, and the part that I really want to talk about probably for the rest of the show, is going to be this blog post that came out in March. And this one is actually from, oh look, it's from Ryan. Who would have figured? Ryan wrote this really interesting and in-depth blog post that kind of talks about a little bit about like the history of the work that happened as they were building out Stripe Radar, some of the decisions that they made, and then where they're landing today, and then what some of the things that they're going to continue looking at and going forward to in the future. That's going to be our main conversation today, right? Like we're going to kind of talk about some of these lessons learned. We're going to talk about like some of the engineering that went into Stripe Radar, and then obviously feel free to go ahead and drop in any questions you have for Ryan, and we'll try and make sure we get them answered live on stream as well. Okay, so Ryan, why don't we start at the beginning, right? And so Stripe Radar is a fraud detection service, right? It's fraud detection service built in Stripe. So like, what does that actually mean from like basic principles? Like, what does it actually mean to be like detecting and preventing fraud? And like, how does Radar actually do that for our customers?
Yeah, that's a great starting point. And I would actually even start earlier than that and going back into like around 2013. Stripe was, just getting started, brand new company. And one of the problems that we were facing back then were these fraudulent payments and dealing with them. So payments would happen on Stripe's merchants. They would get a fraudulent dispute, which essentially means that the real owner of this card did not authorize that transaction and would file a dispute with their bank, which then would make its way through the card networks and back to Stripe. And Stripe saw this and saw at the time, like, hey, this is a really good opportunity to apply machine learning or apply like additional defenses such that we can prevent these disputes from happening in the first place. And if we can do that successfully, that means we're saving our merchants and the people that integrate with Stripe both time and money. So one, they don't have to deal with the fraudulent payments as they come in. So they may have shipped a good off for that or a physical good, and now they're out the price of that good. They're out the money itself because the issuing bank will take it back, and they will get a fee in addition to it just from the issuing network will apply a fee because that was a fraudulent payment as sort of incentivizing you not to process with fraudsters. And so Radar came about kind of as an evolution of our internal tooling and defenses that we had. So internally, they built a version of Radar. This was before my time, but 2013 to 2016, and then it got kind of evolved into the product that we have today, and now is very merchant facing, and it allows you as a merchant to have additional control over, deciding what payments you want to allow and which ones you should block. And so it's kind of where we got to today, but it started just as an internal fraud defense system for Stripe itself.
That's kind of interesting. Here's the thing with products. I know every different merchant is going to have like their own unique scenario, right? And like, how does like if I'm a merchant and I'm like, okay, I'm going to use Stripe, and maybe I have, I don't know, a particular type of business, and it's not the type of business that you're in or like the folks that are down the street in. You know what I mean? Like, how is Radar able to adapt across like these different types of businesses? Because I'm going to assume that they might have different types of needs and requirements and different types of things that they need to get protected against, right? Like, how does Radar kind of adapt to like those varied needs of different merchants?
It's a great question. And as an example, like if you're a merchant that fraud is really expensive for you. So maybe you have like a luxury good. And so if you ship that luxury good out and it turns into fraud, like that is an extremely expensive mistake for you as a business. On the other side, like let's say you are offering some digital service and offering that good and then having it turn into fraud is not that expensive for you. These two businesses both exist on Stripe in many numbers, and Radar has to be able to work for both of them. And so what we allow with Radar is you can kind of like customize two aspects of your kind of like fraudulent payment experience. So there's the ML portion of it, which is, our machine learning models will run behind the scenes, evaluate the payment for fraud, and produce a score that then you can decide, where your threshold is for deciding when you want to block a payment. And so in the first example of this luxury good business, you may decide that you want to take a very low threshold, which means you're going to block more payments because you want to err on the side of caution there. And then if you maybe don't care too much about fraud, like fraud is not a big focus area for your business right now in terms of driving it down, and you want to focus on growth instead of potentially blocking good customers, you just want to allow a lot of payments through. Well, you can tune that threshold kind of in the opposite direction. Like maybe we need a higher confidence of fraud in order to arrive at a block for a payment. And so that's one bucket of controls, and that's largely what I think we'll talk about today in terms of like that machine learning, how it works and how it's evolved over time. There is another aspect, which is with Radar for fraud teams, you can write rules tailored to your business. And so you can say like, hey, if a payment is coming from this country or is over this amount and has this fraudulent risk score, I don't want to allow those payments. Like I've previously faced some fraud associated with that type of payment, and so I'm going to not allow that on me as a merchant.
Yeah.
And so both of those are like really powerful techniques that we do see merchants use to tailor their fraud experience in terms of like the performance or what we're blocking or allowing to their business and their needs.
Now, I know for this conversation, we really wanted to focus on like those lessons learned and not so much the how to do the thing with Radar. But one of the things I think will be interesting for folks to know, for people that are not particularly familiar with Radar, excuse me, is like when I process any types of transactions, let's say I'm using Stripe Checkout as an example, because we mentioned that earlier already today. Like Radar's already on, right?
Mm-hmm.
It's already on and it's already working, right? Like it's not a thing that I have to flip a switch or something that I have to opt into. Like every transaction that goes through Stripe, right, is already protected by Radar. Is that correct?
That's right. Unless you, as a merchant, have taken steps to explicitly opt out or turn off Radar for your business when you sign up, and especially when you're integrating with something like checkout, it's there, it's running, and it's evaluating your payments and doing its best to try and protect you and balance the need to block fraudulent payments, but then also avoid blocking good customers. In machine learning, we always have this trade-off. We call it precision and recall. And essentially, they're always at odds with one another. So if you want to block more fraud, well, one way to do that is just to block more, but that's going to block more good customers.
Yeah.
But you can get better at only, deciding that like, hey, of the things I block, I want to make sure everything I block is fraudulent. Well, one way to do that is to block less with higher confidence, but that means you're going to catch less fraud at the end of the day. And kind of these are always at odds with one another. And you have to carefully balance between the two. And Radar will attempt to automatically do that for most businesses on Stripe and does a good job at finding that right balance. But if you as a merchant want just, a little bit more control, there's also that opportunity to go a bit deeper.
Right. Okay. Well, one of the main reasons I asked is because of a question that we had from Emmanuel. I mean, Emmanuel's tuning in from YouTube. And he's asking, well, why should we pick Radar over 3D Secure 2? And Again, it's almost like I don't feel like you have to pick between the two. Like they both can kind of exist in the same space. And again, radar is just on, right? Like you don't have to opt into it. But Ryan, I'll let you chime in and give your 2 cents on it.
So 3DS is a great tool for catching fraud and also potentially shifting liability, right, from you, the merchant, to the issuer in this case. And so if there was a payment that turned out to be fraudulent and the customer successfully passed a 3DS challenge, then you're not liable anymore as a merchant. So kind of as you mentioned, it's a great tool to use in this world of fraud prevention. It can come at a cost, right? Like going through a 3DS flow um, can have a conversion hit, right? So if you're sending every single payment that your business processes through 3DS, you may see a conversion hit that otherwise wouldn't be there had you not run every payment through 3DS. And if you don't know what 3DS is, like it's not everywhere in the world. Like I myself am in Washington, and I have never gone through a 3DS flow online because it's not as common here in the US yet. But if you go to somewhere like in Europe or in Asian countries, it's very popular as a banking or intervention method that issuing banks will implement. And so I like to see it as it's a tool in the tool set to try and prevent fraud or shift liability. But then in addition to that, you can use radar to actually decide when you want to raise 3DS, right? So because there is that conversion hit, you may only want to raise 3DS as an intervention when there's a medium risk to fraud. So instead of outright blocking it, we can try and recapture this like middle bucket of medium risk transactions that otherwise maybe would be blocked or maybe would turn into fraud. And so there's a spectrum here, and 3DS definitely has its place in preventing fraud.
Right. So then, still, it would be seen as like a complementary tool versus like I got to pick one or the other. I could use them both at the same time, right? And then there'll be a level of symmetry between the two of those.
The last thing I'd add on it is the networks and or issuers may get mad if you are sending all of your fraudulent payment traffic through 3DS to try and shift liability onto the issuers. At least we've seen examples where they haven't been quite pleased with people that get hit with a fraud attack, but then try and shift the liability for all of that onto the issuer.
Got it. And so as we've been talking about these things, I think most of these have been like relevant for online transactions, right? But we also offer Stripe Terminal, and there's like the in-person things that we do. Does Radar have a part to play in in-person payments, or is it mainly like an online transactional type tool?
It's a great question. So today, Radar's role is primarily in Stripe's main business, which is on the online payments path. But as you mentioned, Terminal is up and coming, and we're starting to process more and more transactions in person, and Radar will play a role there too. And I think we'll talk about this a bit later in this call, but one of the things to keep in mind is what data is available to Stripe when we're making these assessments of whether a payment is fraudulent or not. And an in-person payment looks very different internally to Stripe than a payment that's gone through Stripe checkout. Just as like an example, like email address may not be something we have available when an in-person terminal payment is being made. Maybe there was no customer account, for example. And so really all we're working with is here's the merchant, here's the amount, and this is the card that was used to purchase. And based on that information alone, we have to make a evaluation of whether that payment was fraudulent or not. And so I think there's more work for us to do on the in-person side, but it will come in our kind of path and evolution of Stripe Radar.
Yeah, I guess that makes sense because there's less data points that you're getting, right? Like you're not getting an IP address or locale. You're not getting as much information that you could use and run against like these different scenarios to see if it's fraudulent or not. So
exactly, we're pretty much solely relying in that case based on like our assessment of whether this behavior is normal for this card
Yeah.
and this merchant, and that's it. That's all we have.
Got it. So Ryan, I want to start diving into this blog post a little bit. And one of the things that you started talking about, particularly in this first section where we kind of went through the, the lesson one and like the ML architecture, you started talking about how you went from, the simple, logistic regression model over to a fully, DNN model. Like, I'd love for you to talk a little bit about what that was like, going from, I guess just moving from model to model, right? Like starting off simple and then continuously evolving and building into something that would be able to handle some more complex scenarios.
Exactly. I think, going back to when this all started with the first machine learning model at Stripe used to try and detect fraud, I think it was sometime in 2013. The approach is used back then in 2013, even though ML was still, as hot, if not a little less hot than where it is today. They tended to be much simpler, right? Like people, when they're first starting out on ML problems, tend to focus or initially start with what we'll call like simple ML models or simple ML architectures. And really, the reason to do that is to be able to move fast and then also have something that's really explainable. Like these are very simple models, and by nature, you can kind of like pull them apart and try to understand what they're doing under the hood. And based on that, make iterations and or continue to evolve to build a better, fraud prevention defense. And so I think it's natural to start out simple, like logistic regression, which is what we did. And over time evolved to one that we'll talk about in a sec, which was XGBoost, which is another model architecture that came about in around 2016 or 18, which was a way of, training a slightly more sophisticated, but still what I would consider like a classical or traditional technique or architecture. And it does really well, especially in fraud. It does very well at kind of balancing performance and also learning behaviors on kind of this like payments or column like data that we have. And a lot of our fraud models, not counting Radar, but a few of our other ones are still on XGBoost today. So in terms of like how does this strike in terms of like how fancy or state of the art is it compared to like the ease of operations that come with it? XGBoost is like right there in the middle. It's kind of like the best bang for your buck. And so in some sense, there wasn't a ton of incentive for us to evolve it until we started hiring more and bringing in more of this ML expertise. And so when I joined in 2019, there was a strong desire to evolve to the next iteration, like what comes after XGBoost. And we call that wide and deep. And if we scroll down just slightly, you'll be able to see kind of a visualization of what this architecture kind of looks like. And this is where we were, from 2019, 2020 up until this last summer. Was on essentially an ensemble or a combination of XGBoost, which we have been using for many years now, and a deep neural network, which is what you hear about when you hear about any of the like state of the art ML or recent advances in ML. They're on this neural network type architecture where you have various layers of neurons feeding into one another. And this evolution could have been a blog post in itself, going from a classical technique to, this hybrid approach. But we didn't write one at the time. But the idea was like, let's try and get the best of both worlds, where you have one half of your model and on your previous architecture, and then the newer half is kind of more in line with the state of the art, and you try to combine the two in an optimal way.
So was the thought there almost like, hey, let's, we were always planning to evolve into like a deep neural network. Like that was always the plan. So now was this kind of like as you're building this, as you're building the wide and deep, was it initially thought of as a transitionary point, like moving on to bigger things? Was that like again thinking about like the evolution of architecture? You know what I mean? Like I'm going to add a little piece and then I'm going to slowly migrate into something else. Was that what you were thinking?
I think that's a fair summary. When you look at many of the recent advances and just like the latest papers in machine learning and like how to um, build optimal networks or optimal ML models, like a lot of them are on these deep neural networks or DNN type architectures.
Yeah,
And when you're only using XGBoost or these like tree based architectures for ML, you're kind of missing the boat in some sense, right? Like the ship has sailed. The ML research community is like entirely focusing on improvements to this DNN type architecture. Well, tree based models, there's still some research. People would get mad at me if I didn't kind of honor that there is still active research in this area, but it's not where 90% of the ML community is at right now. And so this was very much a stepping stone for us in our kind of like ML journey as a company or as a team, at least. And that's kind of how, or was the motivating factor to what this blog post is about, which is like, this is a changing aspect of what we do. And I would expect our ML architecture to continue to evolve over time.
got it. And so we went from, or at least radar went from, wide and deep, and so now we're in this 100% pure deep neural network, right? Like, so today, this is what the architecture kind of looks like, right? Like using what's it called, Shield Next X.
Yeah, we called it Shield Next. The our service or our systems internally for radar are often called Shield, like many fraud prevention like services at various companies.
Yeah.
Shield, we protect Stripe and our merchants. And then Next is a play off of the paper that we took this idea from, which was called ResNext or a residual next.
Right.
And that's how we got the name Shield Next. And as you mentioned, it is a deep neural network only architecture. And so that XGBoost component is no longer present.
Okay.
And we've since dropped it, which had quite a few benefits. So, I said we get the best of both worlds when we combine XGBoost and a DNN together.
Mhm.
You also get the worst of both worlds in some sense too. So XGBoost, at least the way we were doing it internally, was quite slow to train. And so this is a model that took 10 to 12 plus hours to train on Stripe's data. And it was just the XGBoost component that was really holding us back. So the DNN, our deep neural network side, is heavily parallelizable. So you can, finish that in a few hours of training compared to XGBoost, which took on the order of 10. And that difference in time leads to a lot slower iterations, right? Let's say you were experimenting and needed to train an ML model to understand the results of your experiment. Waiting 2 hours is very different than waiting 10, right? Like it's a whole business day difference in knowing the outcome of whether you helped or hurt the model. And so that was like one of the major benefits that we got in terms of dropping the XGBoost portion and kind of landing on this DNN only architecture.
So as a software engineer, or particularly as a software engineer that does not work on machine learning things, I always think about like when we're moving from architecture to architecture, things like performance, accuracy, precision, like depending on the type of app that you're building, right, are all important, right? Like so, as you're shifting from, you know, like a mixed model, so to speak, to like this pure DNN model, like do you have, I don't know, thresholds or targets that you're trying to hit as you're training it? Because I'm guessing now that the training cycle is shorter, it's easier for you to evaluate and see where you are, and just I don't just instead of training it once for 10 hours, you could train it 5 times to 2 hours each, right?
Yeah. I think one of the big differences between, traditional software engineering and then like ML engineering or being an ML engineer is this kind of difference in trying to predict what the outcome is going to be before you start the work. So when we're kind of in the world where we have the hybrid model with both of them, we could hypothesize about, what we expect to see should we fully drop the XGBoost model and go to a DNN only. Faster training times was kind of expected, and so there's a target metric that we, hoped for, sought after as we were doing the work. But then, like, the main question, right, is like, well, how does the model perform, right? Like, are we getting more performance, or catching more fraud with no increase in false positive rate as a metric? And that's really hard to predict what the outcome is going to be there. You kind of just, the way you do it is you run a lot of experiments, you measure kind of like the performance and these metrics that you care about, and then you kind of see where you're at after them and make a few changes, and then you run more experiments. And it's this like small iterative approach to try and achieve that goal and that outcome, as opposed to like knowing from the start, like, oh yeah, if we ship this thing, like we'll get 10% more fraud, or we'll catch 10% more fraud across Stripe, which is pretty hard to kind of like size or predict. And so in this case, we wanted to move to this new architecture without losing any performance. So our ability to catch fraud should not change as a result of this immediate migration, but we should get a lot of benefits like the training time and iteration speed, but then also sets us up for in the future. All the state-of-the-art research is being done on these types of models, and therefore it should be easier for us to experiment with them than had we not switched.
Yeah, I could just imagine working in the ML lab, and it must be such an exciting space to be, not because of what's happening, on the internet, but like specifically around just being in a space where you're constantly experimenting and trying out new things and seeing what works and what doesn't work. And then even after you get the thing, like there's always something else to look forward to. Like there's always like the next model, right? Or the next algorithm, or the next, how can I increase performance and update my architecture? How can we, become more accurate, right? How can I reduce the training time? Like there's just so much, I don't know, I just feel like it'll be a fun environment to be in. And with that being said, like what are some of the things that you're looking forward to doing next? Because like we kind of was showing in this previous diagram, right? Like so, we went from this kind of a mixed model to like now there's this pure DNN model. Like what are some of the other advancements, what I mean, in terms of again different models and stuff that your team is looking at?
Yeah, as fun as it might be, we there is an internal saying that comes up quite often, which is like, just like the best baseball players have like an on-base percentage of around like 30%, which would be quite good. ML engineers have a 30% success rate with their metric or their experiments or their directions that they try. So it's not all wins, like a lot of failures do build up to get to this point. But in terms of types of work that we're really excited about and have already executed on in many ways, like this architecture shipped last August, and we got around to writing about it in March. And so we've been able to actually explore some of those like next steps ideas. And one of them I'd highlight in particular is this idea of transfer learning in the ML space. And so the idea here is we have this model and we've trained it on, all of Stripe's payments data kind of across every type of merchant. But as we talked about at the start of this call, merchants have different needs, and they also may face different types of fraud pressure or different types of fraud that's unique to their type of business. And so the idea is, can we tune our kind of global model or make a copy of it such that it performs better on different types of businesses? So if you're a software business and what you do is you sell software, you will likely see different types of fraud than if you were, say, in the food and drink industry serving, deliveries or other types of payments like that. So in that case, we can take the model and try and tune a copy of it for this slice of traffic such that then it performs better, meaning it catches more fraud in that space, or it does so without increasing false positives or blocking of good customers. And that ML technique called transfer learning is only possible because we're on this type of architecture. It would be quite difficult to try and do that, before we made this switch.
Got it. You know, when you said that, one of the things that came into my mind immediately was whenever you sign up for a new Stripe account, one of the things that you get asked is what type of business is this, right? So, and I just thought Stripe was just collecting statistics. I never really thought about it, but like now that you've mentioned it, it makes complete sense, right? Because if I'm running a software business, or a software as a service business, it's different from me shipping physical products, right? Because one, I'm not sending things to like physical addresses, right? Like I'm not doing those types of things, right? So that is like a different, I guess, vector of data that you have to deal with and have to be concerned with, right? And so I can imagine me saying, okay, well, I am this type of company, helps your team in the back end to be like, okay, well, let's adjust the model to like adhere to like this particular constraint, right? Because this business doesn't have these type of problems, kind of thing.
Yeah, that's 100% right.
Well, I am glad I knew that. That is amazing. Okay.
So make sure you select the right type of business you are when you sign up to Stripe.
That is very cool. So another thing I know that you spoke about, and I'm going to scroll down a little bit in this blog post. And for folks that have not seen this is on stripe.com/blog. Make sure you head over and check it out. I know one of the other things that you talked about here in this blog post was about features, ML features and feature engineering, right? And again, like I'm not an ML guy, so what does ML feature mean a different thing for your team than it does for, I don't know, the person building a web app, or is there like a particular like what does that mean for you guys exactly?
Yeah, it probably has a different meaning, but it is a common word. So when we talk about ML features, this is talking about the data that is powering our machine learning architecture and the machine learning model that we just spent some time talking about. So this is specifically like the data and like the columns that are going to go into our model to help it make its prediction or evaluation of whether a payment is fraudulent. So an example of a feature, an ML feature, might be the number of distinct cards used on this email address. So when we're making a evaluation of a payment, we'll look at the email and kind of see how many cards have been used with it across the Stripe network. And that number would feed into our evaluation. And there's around 1,000 of these features that power our model. And all of them were like hand selected in some sense, but like built by engineers over the last between 4 and 6 years. And so our suite of like what makes up a payment is quite sophisticated in nature and kind of complete in terms of like the data that we're looking at and the ML features that we're extracting from that data.
So then you'd say, would it be fair for me to say, when you think about features from an ML perspective, it's about the characteristics of the data that you're ingesting? So again, kind of like you said, like, hey, I'm going to bring in a, this person has like 10 shipping addresses, and every time he's made 100 orders in like 10 seconds, and they're all going to like different places, right? Like, would that be considered like a feature? Because no, that's like a type of data, right? And then now we want to bring that type of data into the model as a feature, so the model can recognize and evaluate it, whether it's fraudulent or not.
Yep, that's exactly right. We're taking you as a merchant integrate with Stripe, initiate a payment, right? And we're taking that API request and that payment, which maybe has a amount, email, card, etc., like some signals like that, and we're transforming it into a representation that is well suited for machine learning and able to kind of like feed into these ML models so that they can make their predictions.
Got it. So then, how do you choose what features to implement? Like, how do you prioritize features? How do you decide, hey, well, these are the next set of things that's really important for us to like incorporate into our existing model?
Yeah, the blog post talks about this a little bit, but one thing we do is we review recent fraud attacks. So people attacking Stripe or a merchant on Stripe and committing a lot of fraud, we'll look at those and dive quite deep and try to understand patterns or kind of like theories for how the fraudsters are going about committing their fraud, like any commonalities that exist between these payments. And then we take that and then we form hypotheses at the end of the day, right? Like, if the payment has a pattern where maybe, like you said, like maybe there's a lot of emails and shipping addresses, and the same email and shipping address are always used together, but there's quite a number of different amount, like more unique patterns or pairs of these two attributes that we're seeing in this attack compared to what would be normally expected on this merchant. So like that deviation from normal, and we're able to then test and write a feature for exactly that. Had we had this feature, what would the model have done? Like, would we have caught this fraud attack if we had these features at that time? And based on answering those questions, we can decide and prioritize whether we want to actually ship or launch these new features. And then we just do that over and over again. And, often we'll come up with ideas for features that maybe weren't relevant for this attack, but just would generally be useful in our model. And we can test those at the same time.
Is there a relationship between the features you want to implement to the model that's like the current model that's active? So I can imagine, hey, we have like this backlog, hypothetically, we have this hypothetical backlog of features, and looking at the current model, we might decide, okay, to add these, we need to change, or we need to go back to our previous thing, or it's just good enough, but we're going to only do the first half. Like what's the relationship between feature and model, and you making the decision of how to implement those features?
Let me know if you'd like to join our team, because that's such a good question, and is exactly what we face all the time, which is actually more from like almost like a scalability perspective, right? Like computing these features isn't cheap, and we may say like something like, oh yeah, the number of distinct cards on that email address, to go back to that example, but we need to do that for every single email address and every single card on the Stripe network. And so you can imagine how quickly that scales out of hand. And then you have 1,000 of those. So we often face situations where, in order to add new features, we actually need to get rid of some previous features and old features in our ML model. And so the way to go about that is actually fairly simple, right? Like you can experiment with, or conduct an experiment where, hey, if I remove these 10 features from our model, maybe they're really old, or maybe we've done some other ML technique to understand how important they might be. Let's just remove them and see what happens to our performance in an offline test, like back test that. And based on that, we can come to a conclusion based on like a statistical analysis of like, based on removing those features that had no statistical impact to our model, which then frees up some room for us to be able to add more new ones, which could impact our model and help it get better. And so this kind of like trade-off of, in order to add 10 new ones, you need to deprecate 10 old ones. It's not that quite explicit, but we generally do face this situation where we have to decide what we want to add versus what we should drop. And we do that through experimentation.
Got it. So inside of the blog post, and even in this conversation, so you've mentioned the Stripe network, right? Maybe we could talk a little bit about like what does that mean? Like what is quote unquote the Stripe network, and then how does it actually influence, how Radar functions?
Yeah, the way I would describe it is, if you hired me and I was a ML engineer at your company as an individual merchant, and you wanted me to build a fraud model for you, that would be quite hard unless you were a very large merchant. You probably don't have enough data to reliably train a sophisticated ML model. And then also, I can only use the data to build a fraud system based on what we see at kind of the merchant level. And so when we say Stripe network, what we're saying is like, all of these merchants, like tens of thousands, millions of merchants process on Stripe, and all of their data feeds into this kind of like network effect where we can use the signals on one merchant. And so if one merchant was faced with a fraud attack and the signals relevant for that, the model, when it's evaluating whether this other merchant is under a similar fraudulent attack, it has that context between the merchants, because the model is evaluating these signals, like the number of distinct cards on an email has like two different dimensions, right? There's the Stripe network dimension where we look at all of the data across Stripe to calculate it. And then it has the individual merchant dimension, which is like for you and you or your data alone, how many unique cards were used with this email. And those could have very different values depending on how prolific fraudsters are trying to attack the Stripe network, or just in general, how often an individual is shopping at different Stripe merchants. And so the difference in predictive power, or our ability to stop fraud with very low false positive rate, is directly proportional to how powerful these network effects are and our ability to capture them in our ML itself.
I can imagine, being plugged into that. One of the things that you get is just a tremendous amount of data, right? Like it's just data upon data upon data. And I can imagine, is there a balance between the amount of data you train on and like the actual effectiveness for preventing like false positives? Like, is more data always a good thing, or is there, again, with that too, is there like a balance between this is just enough and then I don't know, the rest of this is test data, right? We'll test against this and train on this. Like, how do you kind of see that?
The answer to that is so dependent on the features that you've built for your ML and also the architecture that you're running on. So actually, if you scroll down in the blog post, I think we have a plot or a graph that talks about this, which we found for this model architecture and our current iteration of features, we're actually seeing like fairly low diminishing returns as we scale up our data size. And in this case, we went 10x our regular or our current size of our data. And we just wanted to see, like, are we still seeing performance gains? In this case, measured as like recall at a fixed false positive rate. And it turns out we do. And that was an extraordinarily exciting result, which showed that we can just keep throwing more data, which is not so simple to do, but is like kind of easy in theory compared to like building more features or iterating on the architecture. This is just like, hey, throw more data at the problem. And we're still seeing gains from that are worth pursuing, which is an exciting state to be at compared to any of the other options that could have happened. But that's not always true, right? Like if we looked at our previous model, or even some of our other ML models that we have running behind the scenes, like they don't scale with this property. And in part, it could be due to their ML architectures aren't using this architecture yet.
So speaking about performance, like when merchants are plugging into Stripe, right, we have like different options. Is there more or less effectiveness with Radar based on like what their integration points are?
Yeah, it's a really good call. So we heavily depend on the data that is sent to us. And a lot of times that data is captured automatically, right? Like the payment amount is present because you're making a payment. Yeah. You're generally need a card number, right? Because the payment needs to be on something. And then if you're using integrations like Stripe Checkout or Stripe.js, we're able to collect information about the device that's making the payment. So like the IP address or the device itself, and whether it's the same device as used previously on this card. But some fields are optional, right? Like email address is a great predictor of whether a payment is fraudulent, especially if it's tied to like a customer account on your merchant. But if you don't send us the email address, Or if you're integrating with Stripe in a way that doesn't give us access to the IP address or those device signals, then it can really hurt Radar's ability, because you can imagine all these features that we've built, we can no longer calculate them. If you don't have an IP address, that itself is a signal, but we're not able to calculate the other 400 plus features that we could have calculated if the IP address was present. Yeah. And so we have some public docs that talk about Radar's integration, which I think is in your next tab. And based on those, this doc, these public docs themselves are a great reference when you're working to integrate with Stripe, and you may deviate from the common path of something like the payment links or checkout or Stripe.js. These are really important considerations to keep in mind in terms of if you're going to rely on Radar for fraud prevention, then the data you send us and the quality of it directly ties to our performance and our ability to stop fraud without hurting good customers.
Yeah. Okay. And this is a really interesting doc too. If folks are interested, excuse me, if folks are interested in reading this, I'm going to put up the link really quick. So if you want to go ahead and read through this, learn about some of these details, and learn about the Radar integration quality between these different options, make sure you go ahead and check out that link that I'm sharing now at the bottom of the screen. Okay, so we're getting close to the end, but I feel like there's so much more that we have to talk about. Let's talk about. So we spoke about features, right? We spoke about features being like the type of data that's getting injected, or the model supports to be able to make these decisions. What are some of the other trends or the newer trends that you're seeing in terms of bad actor fraud, right? Because I'm guessing you have to constantly be aware of, oh, now they're gonna try this today, and this is a new thing, and and so now I'm guessing that too also makes you consider, okay, well, these are the features that we really need to think about, because this particular technique is on the rise, whereas these other ones not so much, right? Is that a thing that happens with you all?
Yeah. So one fun fact, we're monitoring various forums where fraudsters will kind of congregate and try to discuss ways in which they'll abuse Stripe or Stripe's merchants. And so in some sense, we try to get ahead of the curve because we can see what they're talking about and sharing with one another, because there's this community of fraudsters that exists.
Yeah.
And one example is they like to target merchants that have these poor integrations. And so our defenses for a merchant that is integrated with Stripe directly through our API and is not using checkout or payment links or Stripe.js, our defenses for that type of merchant are going to look quite different than a merchant that is purely just using checkout and sending us lots of high quality data. And in some sense, we need to be slightly more aggressive with the merchants that choose that former integration path where there's less signal or less data, because we know fraudsters are going to hit those merchants particularly hard. And that kind of difference in our stack is one area where we've started to invest more into.
Yeah. I can just imagine there's a room somewhere in a Stripe office where there's just a bunch of folks sitting down watching whatever forum technology these folks are using, just watching forum posts and reading it, and just taking notes down. That must be such an interesting kind of space to be in, and kind of just watching that.
Yeah, you kind of get to see it happen firsthand in real time, which is stressful, but fun as well.
That's funny. Okay, so we spoke a lot about Radar and the evolution of Radar, and some of the things that you and your team are doing in terms of improving the performance of the models and implementing features and things like that. I kind of want to talk about the other side of the table. So after something has been flagged, right? What happens next? I don't know, what happens to me as a customer? What happens internally? How do we communicate with the people involved, right? The necessary stakeholders that, oh, okay, well, this is a problem, right? How do we, what are the next steps post flagging?
Yeah, a big part of this is merchant explainability and basically conveying everything we've talked about today and all of the machine learning that's happening behind the scenes and digesting that and surfacing it in a way that a merchant can understand. And so part of the Radar product when you're working with it on Stripe is, we expose the Radar risk evaluation or the score itself. So you can try and understand how risky an individual payment was. And then further, what we've built is we've tried to be able to complement that score and give you insights into maybe how that, or more insights into how that score was derived itself, so that you can see additional signals beyond just a single number. And that we called risk insights, which tried to, or accomplishes that by surfacing around 10 or so additional signals that correlate with fraud or could correlate with fraud, so that you yourself can see and go see, like, oh, how many email addresses were associated with this customer, or how many fraudulent disputes have happened on this IP address before. And it gives you a little more insight into what was happening behind the scenes to try and explain or complement our machine learning.
And so if I'm not mistaken, and I believe I've seen a little bit of the UI about this before. I believe it shows you, like, I think there's a map, or like a geographic map, and then there are, like you said, like bullet points of, well, these are the sets of things that we detected, and so this is why you have a really high fraud score, right? And why we didn't allow this payment to go forward, right?
Yeah, I would say it's not meant to be, or right now it's not a perfect explanation, right? We're trying to digest those 1,000+ features that our ML took into account into a series of like 2 bullet points is quite a hard problem. It's like at the kind of state of the art of machine learning explainability, like this is quite a hard problem to achieve or solve. And so we're trying our best to both like give you that high level summary, but then also provide you additional data points so that you can make your own interpretation of like whether this was risky or not. And we know there's more to do here because we ourselves have some internal tools that we've been working on in terms of like better ML explainability. And like many products, like we're trying to dog food them internally first and then use that as kind of a stepping stone to releasing it to our merchants and giving them that power.
Got it. Okay. So today, let's say today I'm a merchant, and customers are sending me transactions, and let's say, I don't know, 1 in every 2,000 is a problem with it. Hypothetically, I'm just making up a number. I'm not saying this is not racist. I'm just making up a number. What can I do as a merchant at that point, right? Is there like a number? Because sure, maybe I can see the score and I can see things, but like, what can I do? Right? Like, can I call someone? Can I email someone? Do I have to get my account manager? What are some of the steps that are available for me post flagging?
Yeah. I think it depends on the context. Like, is this a payment that was blocked by Radar and you believe it was not fraudulent? Or was this a payment that Radar maybe missed but evaluated as like medium risk and you believe it might be fraudulent? And so the actions you might take in either scenario may be like quite different. So in the example of like, Radar maybe missed a payment, but you suspect it might be fraudulent. Well, one thing you can do as a merchant is maybe don't ship them the physical good that they purchased until you can perform more due diligence of whether they were fraudulent or not. Maybe emailing them and asking them to confirm a few details would be an action you could take there. Or if you don't want to deal with that at all, you could just refund that payment that you believe was fraudulent that Radar missed. That way you don't get any fraudulent dispute or fraud indicators from the network on that payment. And in the case of like the former, where Radar maybe blocked a payment, but you weren't sure it was fraudulent, ways you can do that, you can add this customer to an allow list. If you're very confident that this was not a fraudster, you can have it bypass Radar. or you can, adjust your risk settings and threshold like we talked about at the start, where you can, decide you want to block less payments because maybe fraud isn't a major factor for you as a business right now.
Okay, that makes sense. So again, we as merchants and other folks, so we do have options. So all just depending on whatever it is that we need to do. For folks that are watching, whether it's the whole time or not, here is the link for the blog post that Ryan wrote, and that contains a lot of detail about some of the things that we've been discussing in this show today. Ryan, I guess I'd say for folks that I guess a little bit more interested in some of the things that we've been talking about and some of the things that your team is doing, what are some good ways for them to maybe reach out to you, or are you on LinkedIn and social things, or how can they interact with you and learn about some of this stuff more directly?
Yeah, LinkedIn is a great place. So on there, if you search my name in Stripe, it should come up. But then also, my email is just my last name @stripe.com. So if there's specific questions we didn't quite get to and you'd like to reach out, I'm happy to answer them there.
Awesome. Well, folks, this has been a great conversation for me. I feel like I've learned a lot. And again, I'm not a machine learning person, but I feel like there's so much good information that's there. And like I said in the beginning, I love it when security is protecting me in the background and I don't have to worry about it. And I feel like this is one of the things that makes me feel safe and comfortable using Stripe, because of some of this work that's happening in the background. A lot of the hard work and effort and engineering that's happening to make sure that we're protected against some of these fraudulent transactions and a lot of these bad actors. So with that being said, thank you all so much for joining us. We will be back next week with another episode of Stripe Dev Chats. Hope you join us next Wednesday. Actually, we'll be here this Wednesday and next Wednesday. So the next 2 Wednesdays, make sure you come and check us out. But with that being said, thank you all so much. Thank you, Ryan. Appreciate you being here. And
thank you for having me.
And that's a wrap. Bye, everyone.